Hello everyone, welcome to my channel. Today I am going to explain about the extendable hashing. Extendable hashing I have prepared two video. Part 1 I have explained about the extendable hashing and that what is the extendable hashing, what are the component is used in the extendable hashing, what is the algorithm of the extendable hashing, and what is the advantage and disadvantage that I have explained in the part 1, and this is the part 2. Here I have taken one example that I am going to explain here how the extendable hashing is working, that I am going to explain here. So please, before watching this video, please watch the part 1 so you can easily understand this video. So here I have taken one example and the element is given and bucket size is given. Now according to the extendable hashing algorithm, first step is saying that first you have to analyze your elements. Is it string? Is it string or character or float or integer? So if it is string and character, you have to take the ASCII value of it. And then after, here I have analyzed my data is integer. Next step is saying that convert all these number in a binary format. Convert all these in a binary format. So I have converted my all element in the binary format. Next, what will we do in the third step? It's saying that in a starting, global depth and local depth is always 1. So if in a starting we'll put that the global depth and local depth equal to 1. Thus, the hashing frame looks like this. So if it is my global depth is 1 and local depth is 1, that will looks like that frame, my hashing frame looks like this. So here saying that the global depth is 1, it means that the number of directory is 2 to the power global depth, 2 to the power the global depth, and my global depth is 1. My global depth is 1, so total directory bit is 2. So total directory bit is 2. So I'm working, the extendable hashing is working on the bit. It means that the total bit is 0 and 1. 0 and 1. So 0 is the one directory ID and 1 is the one directory ID. So here if you see that 0 is the one directory ID and 1 is the one directory ID. 0 is pointing to the 0th ID bucket and this is pointing to the ith directory ID bucket. And this one is local depth. Local depth is associated with the bucket and global depth is associated with the directory. Now I am going to store all these elements one by one. I will going to store all these elements one by one. We'll see the steps how we're going to store that all these elements in the hashing frame. So here I am going to store the 16. Here I am going to store 16. For storing the 16, what is the procedure? So here given that the global depth is 1. If global depth is 1, we'll take 1 LSB bit. If global depth is 1, we'll take 1 LSB bit. If it is 0, it will going to store in this bucket. Means 0th directory ID bucket will going to store 0th LSB value. If it is 1, if it is the LSB bit is 1, so that is going to store here. But here I am going to store 16 and my 16 LSB bit. LSB bit, it means that this is the LSB bit and this is the MSB bit. So here I am going to work on the LSB bit. I will take the LSB. Global depth is 1, so I will take 1 LSB bit. If it is global depth is 2, we will take the 2 LSB bit. But here by global depth is 1, so I am taking 1 LSB bit. On that basis I am storing the element in the bucket. So 16 is having 1 LSB bit is that is 0 value. So 16 is going to store here. Now if I am going to store 4 and their binary bit is 1 0 0, if you see that 1 LSB bit, because here also global depth is 1, so we'll see that 1 LSB bit is also 0, so 4 is also going to store. Now next element is 16. 16 1 LSB bit is also 0, so 16 is also going to store, right? Now I'm going to store the element 22. Now if I'm going to store the element 22, then what we will do? So here also our global depth is also 1. Here global depth is also 1. Here global depth is also 1. So what we will do here in inserting the 22, here also take that one LSB bit, and that too is also 0, so that is also going to store here. But we have seen that in the starting the bucket size is only 3. The bucket size is 3. It means that the single bucket can store only 3 element. But here 22 came, it means that there is a 4 element, and this situation is called overflow situation. It means if I take the real life example, suppose there is a hostel and a room is defined with a seated, means 1 seated room, 2 seated room, 3 seated room, like that. If it is single seated room, it means that single student can stay there. If it is double seated, it means that 2 student can sit. So similar like that, here this bucket size is having 3 seated, capacity is 3 element to store, but the 4th element come, then overflow occur. So 22 came, it means that overflow condition come. Then extendable hashing is saying that if this type of situation come, you have to check 2 things. Local depth of overflowed bucket, means this bucket, 0th directory ID pointing to the bucket, that bucket is overflowed. So what is the local depth of this bucket? This bucket local depth is 1 and global depth value is 1. So if it is both is equal, if it is local depth and global depth is equal, what will you do? Bucket split you do, directory expansion you do, and increment the local depth of overflowed bucket as well as global depth. Now if you expand this directory, first you have incremented the global depth. So yeah, now your global depth became 2. So your global depth is now 2, as well as your local depth of overflowed bucket also become 2. Then tell me the number of directory. Number of directory is what? 2 to the power 2. Global depth value is 2. So total is what? 4. If you want to convert this in a binary, you will get that 0, 0, 0, 1, 1, 0 and 1, 1. So these 4 directory you are getting because your global depth is now 2. So this is called directory expansion. Now we'll do the bucket split. So this bucket is divided into 2 parts. This bucket is going to split it into the 2 parts. One part this one, another is this one. This bucket is split in 2 parts, and now the local depth is 2 now. So local depth is 2 now, and this is still 1. Right? Now one more thing is coming. See, global depth incremented, number of directory also expanded. So this is become the new directory, and this split is also happen. Then the concept come here. Now whatever the element is here, 16, 4, 6 and 22, we have to again restore this element in the new bucket on the basis of what? 2 LSB, because now your global depth become 2. Now your global depth is 2. So you have to store all these elements on the basis of the 2 LSB bit. And one more important thing is that which directory ID is going to point which bucket. That's very much important question, that you have expanded this. You have expanded this directory, you have expanded the directory, and you have also splitted the bucket. Now you got this bucket and this bucket. Now how you previously there was a two directory 0, 1. So you are saying that 0 is pointing to the 0 bucket, 1 is pointing to the 1 bucket. But what about this one? What about the new one? For there is a question. So what will you do while making this pointer? Means where this 0, 1 is 0, 0 is going to point, which bucket 0, 0 is going to point, which bucket 0, 1 is going to point, which bucket 1, 0 is going to point, which bucket 1, 1 is going to point. So for that reason, what will you do? Here you see that 0 is pointing to the 0th bucket. So go and check wherever the first LSB bit is 0, wherever the first LSB bit is 0, wherever the first LSB bit is 0, then you check that immediate another bit, means immediate another bit. If it is 0, that is one bucket, that is going to point to the one bucket. If it is 1, then that is going to point to the another bucket. So do remember how you make that pointer, this connectivity, how you say that this 0 directly is going to point to this bucket, because first of all you check that 0th bucket, where is the first LSB is 0. So there is a 2 places having 0 0. This is this one and this one. Now we check that the immediate next bit, that is 0. So this is going to point to the one bucket, and immediate next bit is 1, that's going to point to the another bit. Remaining is wherever the LSB bit is 1, because here the LSB bit is 1, here we were not doing anything. So wherever the first LSB bit is 1, wherever the first LSB bit 1, that is going to point to this bucket. So wherever the first LSB bit is 1, that is going to point to the this another bucket. Why so? Because we were not doing anything here. So this is this 0 1 0 1 and 0 1 and 1 1 is going to point to this bucket. Okay, now what we will do, we have made that pointer, we splitted that, expanded that. Now what we will do, now we have to store this element, this 16 4 and 6 and 22, we need to store this in the new bucket according to the new directory ID, right? So what you have done, bucket split done, directory expansion done, local depth is implemented and global depth is also implemented. The next step is that you have to rehash, means you have to insert all these element, the overflowed bucket element again to the new bucket, that expanded bucket, splitted bucket. So what we will do next, if you want to store the 16, 4 and 6 and 22. Now if you want to store this, then you have to check that what is the global depth. Global depth is 2. So now you check 2 LSB bit. Now we check 2 LSB bit, and accordingly you have to store 16 is having 2 LSB bit is 0 0. So 16 is going to store here. In 4, 2 LSB bit is 0 0. So 4 is also going to store here. 6 is having 2 LSB bit is 1 0. So 6 is going to store there. And 22 is having 2 LSB bit is 1 0. So 22 is also going to store there. Now what we will do, one more thing is, remember, if it is the overflowed bucket depth is less than global depth, there only you split the bucket and increment the local depth. So do remember, it will going to use in the next step. So here what will you do? If you want to store 24, suppose if you want to store 24, and what is your global depth? What is your global depth? Global depth is 2. So check that 2 LSB bit. Global depth is 2. So you will check that 2 LSB bit, and that to 0 0. So where this 24 is going to store? In this bucket. In this bucket, because 0 0 is pointing to this bucket. So 24 is going to store, right? Now if you want to store the 10, check that 2 LSB bit, because your global depth is 2. So 2 LSB bit is 1 0. So 10 is going to store here. Now what will you do? If you want to store the next element, suppose my next element is 31, 7 and 9. Now I am going to store 31, 7 and 9, and I will check that 2 LSB bit of the all three element. So here see that 2 LSB bit of the 31 is 1 1. So 31 is going to store in this bucket wherever the 1 1 is pointing. So 1 1 is pointing to this bucket. So here is going to store, and 7th 2 bit is also is 1 1. So this is also going to store, and 9 is also 0 1. That 2 also going to store here. right? So far here while storing the 24, 10, 31, 7 and 9, there was a no overflow occur here. There was a no overflow condition. So simply according to the global depth, you are taking that bit LSB bit, and you are storing the element. Now if I am going to store 20, now I am going to store 20. So what is my global depth? My global depth is 2. Again take 2 LSB bit. If you take 2 LSB bit, what happen? You will going to store where? In this directory. So directory ID is 00. So there is going to store. But we know that our bucket size is, the given bucket size is only 3. The bucket size is only 3. But here there are 4 element. Bucket size is 3, but there is a 4 element. Means there we have a 3-seated room, but 4th student also wants to come in that room, but that's not possible. That situation is called overflow. So overflow occur here. Now what will you do? Check that the global depth as well as local depth of overflowed bucket. So what is the local depth of overflowed bucket? 2. So here also situation is that GT equal to LD. GT equal to LD. Then what will you do? Directory expansion. So here GT equal to LD now become what? That value is 3. GT if it is equal, then both is increment. Then bucket is splitted, bucket is splitted into 2 part. This is splitted into 2 part, and directory expanded. This is expanded, as well as the local depth and global depth is incremented. So global depth is 2 and local depth is also 2. So both is now become 3, and number of directory is what? Number of directory is 2 to the power 3. You will get what? You will get 8 directory. Total directory you will get 8 directory, and that too nothing but a 0, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, and this one you will get that this much directory, and this is called the expanded directory. This is the expanded directory, right? Now perform the split. So if you perform the split of overflowed bucket, so this bucket now become 2 and this is 2. So total bucket is how many bucket total? Total 4 bucket. So total now we have a 4 bucket. Then now we'll see that how we make this connectivity. See, I have expanded the directory. This is expanded directory. This is expanded directory, and I have also performed the split. After the splitting we got that 4 bucket, and also incremented the GD and LD. So have splitted this one. So now this splitted one become this local depth become 3. This one become also 3, and this is still 2, and this is still 1. Here we will not going to do anything. Now we see that the how we make that this 000 is going to point to this bucket. How we will decide it? So for that reason, what will you do? Here we can see that you are splitting the zeros directory. So go and check that wherever the last 2 LSB bit, wherever the 2 LSB bit is 00, wherever the 2 LSB bit is 00, and immediate value also you see that. If it is immediate value is 0, that pointing to the 1 bucket, and if it is immediate bit is 1, that's pointing to the 1 bucket. If it is immediate of after the 2 LSB bit, immediate next bit is 0, that is going to point to the 1 bit, and if it is immediate after the 2 LSB bit, 1 bit is 1, the 1 that is pointed to the another bit. So understood this connectivity? This is done. This is done. Now coming to the 0, 1. Coming to the 0, 1. So wherever the 0, 1, go to the 0, 1. Wherever the 0, 1, wherever the 0, 1, and wherever the 0, 1 as well as 1, 1, because 0, 1 in this directory you can see that 0, 1 and 1, 1 both is pointing to the this bucket. Both is pointing to the local depth 1 bucket. So wherever the 0, 1 and 1, 1, wherever the 0, 1 and 1, 1, all these going to point to this bucket. Wherever the 0, 1 and 1, 1, that is going to point to this bucket. Now coming to the next one. So wherever the 1, 0, wherever the 1, 0, that is going to point to this bucket. Understood? So split is done in the 0th, 0th. So that is splitted. So wherever the 0, 0, you will see that the immediate one 0 bit is going to point to the 1 bit and 1, 1, 1 is going to point to the another bucket. Remaining is what will you do? Wherever the 0, 1 and 1, 1, all these going to point to this bucket, and wherever the 1, 0, wherever the 1, 0, wherever the 1, 0, that is going to point to this bucket. Now overflow occur. Now what will you do? You have to store again this 16, 4, 24 and 20 in the new expanded directory and new splitted bucket, because you have to store again, you have to rehash here, you have to perform rehash on the basis of what? Here now we have a global depth is 3. Now we have a global depth is 3. So according to the 3 bit, now you have a global depth is 3, then you have to check last 3 digit. So if you check the last 3 digit of 16, the 3 LSB bit is 0, 0. So this 16 is going to store here, and 4 also, if you check that, the 4th 3 LSB bit, you will get that 1, 0, 0. So check that the 4 is going to store where? 4 is going to store there, because 3 LSB bit is 1, 0, 0. So 3 LSB bit this one, so 4 is going to store there. 24, if you see the 24 binary bit, then you will get the 3 LSB bit is 0, 0. So 24 is also going to store there. And next is 20. 20 is here, look at here, the 3 LSB bit is nothing but a 1, 0, 0. So this 20 is also going to store here. And remaining is you just copy it as it is. Remaining 6, 22, 10, all this is going to same. So nothing you will do. There is no changes here. There is no changes here. No changes here. Right? You will only perform rehashing wherever the split happened. Wherever the split happened and overflow occur. That you do. Next, what you have to do, suppose I am going to store next element is 26. Now I am going to store the 26, and 26 binary digit is this one. Here my global depth is 3. Here my global depth is 3. Whenever you are going to insert new element, first check that the global depth. Whatever the global depth is given, that much LSB bit you check, and accordingly you store in the bucket. So here my global depth is 3. So 26, 3 LSB bit I will check, and wherever this bit is going to point, whichever the bucket is going to point this directory, there will store 26. So go and check 0, 1, 0. Where is that? 0, 1, 0. 0, 1, 0 is pointing to this bucket. No. 0, 1 pointing to this bucket. Right? So 26 is going to store here, but problem is that we know that our bucket size is only 3. My bucket size is only 3, but here the 4th person is came, and 4th person is nothing but a 26. So this situation is overflow, and I have already said that if local depth and global depth, if local depth of overflowed bucket, I am not seeing the other one, overflowed is occur in this bucket. So what is the local depth of this bucket and global of depth? So if it is local depth less than global depth, if local depth less than global depth, then what will you do? Simply what will you do? Simply split this bucket. Simply split this bucket into two parts. We simply split in this bucket into two parts, and there is a two connectivity now. There is a 0, 1, 0 is pointing to this bucket, as well as 1, 1, 0 is pointing to this bucket. So what will you do? One pointer is going to point to this bucket, another pointer is going to point to this bucket. So same thing I have did it here, and afterward what we will do? Increment the local depth. So previously it was 2, now it become 3. Now it become 3. This one become 3, and next step what will you do? You have to rehash these 4 element. Means you have to again store this 4 element in this 2 splitted bucket. So I'll show you that again how you make this connectivity, how will you do this. So after splitting this bucket, if you split this bucket, that is converted into 2. So 2 bucket and 3 is already, so total 5 bucket. So total is 5 bucket, and this is as it is, whatever the depth it is given. This is 3, this is 3, and this bucket is splitted, and now incremented the local depth. This is also become 3. Here there is no directory expansion, so whatever the directory is given, same directory I have written here, right? And here also 3, and this is 1. This is 1. This directory local depth is 1. Now I will tell you how you make that this pointer. How will you do that? This is almost same. I am not doing anything here. This is also element is 16 and 24. Here I am not doing anything. I'm not touching this also. This is completely same. Here also I am not going to touch. I am going to only do here. I am going to only do thing here, because I split it here na. So we'll see that previously there is a 2 pointer, 0, 1, 0 is pointing to this bucket, as well as 1, 0, 1 was pointing to this bucket. So I split it and I said that this is pointing to this bucket, 0, 1, 0 is pointing to this bucket, and 1, 0 1, 1, 0 is going to point to this bucket. So simply previously 2 pointer was pointing, now there is a single pointer to point to the 1 bucket, another pointer is going to point to the 1 bucket. Remaining as it is I copied because of local depth was less than. So simply I have done bucket split and incremented the local depth. And third step is that you perform rehash. So this is my final step. This is my final step. And after the rehashing of 10, 26 and 6 and 26, 22, if you store, then you will get that. If you see that the 10 binary bit, you will get that 1, 0, 1, 0, and here your global depth is what? 3. So you just check the 3 bit, and where is that 0, 1, 0? Check that 0, 1, 0, 0, 1, 0. So 10 is going to point here. Similar like that, if you calculate the 26 binary bit, and according to the third bit, according to the 3 LSB bit, you will get same 3 LSB bit is 0, 1, 0. So this is going to store here. And for 6, if you do that 6 binary bit, then you will get that 0, 1, 1, 0, you will get that. So if your global depth is 3, so 3 LSB bit, if you check that, so check that 1, 1, 0, that's pointing to this bucket. So 6 is going to store. Similar like that, if you do 22 binary bit, the last 3 digit you will get that 1, 1, 0. So because of that reason, 22 is also going to store. Remaining I am not touching here, remaining as it is, because there is no overflow occurred. So remaining I simply copied it. Simply I copied it, so I am not doing anything, not even the pointer and not even the value. So only I am performing the wherever the overflow occur. So this is all about the extendable hashing. I have explained here the extendable hashing with example. And the part 1 I have explained all this about the extendable hashing. I have also explained the algorithm there. But the main part is to remember in the algorithm is that 2 things. Only is that local depth of overflowed bucket is equal to global depth. One thing is this one, just remember. Then 3 thing you do that you remember. And second step I will tell you that if it is local depth less than local depth of overflowing bucket less than global depth, then you just perform the bucket split and increment the local depth. That's all that you remember. One thing is this one. Second thing I will say that whenever the inserting the element in a bucket, just check that the global depth. If it is global depth is 2, take 2 LSB bit according to a store. If it is global depth is 3, then take 3 LSB bit and then a store. That is the second point. Third point, I will tell you that what will you do. Third point, after the splitting the bucket, then you will see that the bucket is increased, then you will get confused that how do I assign the directory a bucket. How will you assign the directory to a bucket? So for that reason, what will you do that whenever the split happen and expansion happen, whenever the split happen and expansion not done, that is very much easy. And if it is expansion also done and bucket is also splitted, that time what will you do? Check that the previous global depth, whatever the global depth of previous, suppose previous was 2, so we'll see the 2 bit, we'll see that only 2 bit, and then check the third bit. And similar like that, suppose this 10 is splitted, so 10, wherever the 10 go there, this 100 used to always you are splitting into the two part, you are always splitting in the two part. So 2 bit and the 0, because this is two different, this is the different directory ID, this is the different directory ID. So this become the one, this become the one bucket, and this become the one bucket. Like that you can do that whenever the splitting happen. So that's all about the extendable hashing. If you get any doubt at any time while watching the video, you can comment anytime. I'll be available to get that answer for the clarify that global depth. Thank you for the watching my video.